This is the Energizing India podcast.
Apart from causing a lot of traffic, commercial trucks play a very key role in running everyday life in India. However, over the years, these ICE trucks have been major contributors to environmental pollution. Addressing this particular issue today, we have Rohan Shravan, the CEO at Tresa Motors, one of the few companies that is actively building intellectual property or IP in India, and that too in a space largely dominated by legacy players. This is going to be a fun conversation. Rohan, welcome to the program.
Hey, glad to be here.
So Rohan, you graduated from IIT Kharagpur, and from there you worked in various design houses, then also worked a bit in AI. You have quite a extensive sort of experience in that particular front. So can you just tell us more about your journey?
So it's a pretty interesting journey actually. 2008 mechanical engineer IIT Kharagpur. In 2007, I started working on a concept of a device, but the device was based on NVIDIA as a platform, and they were not replying back to my emails. And somehow I had to get to them to understand how can I get the reference design. And one of my friend posted my CV to 𝐃𝐤𝐈. I joined 𝐃𝐤𝐈 for 3 months. They posted me to US, went to US, met NVIDIA, got a reference platform, resigned and came back. And when I came back, I wanted to become a monk. Left everything because NVIDIA said that they're going to give me a platform after 6 to 9 months. So I thought, why not explore some of the spiritual aspects of Vedas. I'm pretty interested in that concept. So went to Ladakh, went every single monastery possible, and my driver got fed up because no monastery is ready to take me as a monk. That concept is actually there, but it's a marketing concept. So so all the monks said that why don't you come back in July when you can actually be here and become a monk. Finally, my driver told me something interesting which I still remember. What I'm looking for is inside me. I have to go back and search myself. And that actually started a journey. 2009 was spent in making this device called Atom. Notion Inc. Atom was very famous in 2009, 10, 11. We showcased our device in Las Vegas CES, got pretty much good recognition as well. Started manufacturing it. We sold across 80 plus countries. But within 1 year, NVIDIA came back and said, we can't give you the processor because we are exclusive to Motorola.
Oh, wow.
And Google came back and said, we can't give you the Android operating system because it is exclusive to Motorola. And Google had bought Motorola at that time. We're talking about Motorola Zoom. That was the first tablet which came out from Android. So what I learned there is, unless you own the IP, you should not do something like this. You become Carbon, Micromax, Lava. The life is not going to be much as if you're an assembler. So manufacturing for me was 2009 to 2016. Then 2014, I started one company where we started focusing on designing axial flux motors. It took around 6 years to get the concepts. We tried different variants, different kind of technologies, burned all the personal savings in designing the inverters. We needed inverters which can work on silicon carbide switch circuits, and they're very expensive. Each one of them was something like 50,000, 60,000. Yeah. Burned a lot of stuff, but finally 2022 it was ready. Since 2016, I've also been running School of AI, where I teach AI on Saturdays, 6:30 a.m. I've taught more than 7,000 students in deep neural networks. And I also started a company called 𝐃𝐞𝐞𝐩 in 2016 that is into sensor fusion. Sensor fusion, there we use a LiDAR, a normal camera, and thermal camera integration to, at real time, design the hyper accurate 3D model of a site, which is now in construction. So most of the embassy buildings are on our platform. Every 1 in 3 construction building in commercial real estate in the Bangalore city is on our platform. But Tresa literally started with the motor being ready and looking at people who are in our ecosystem. And it touched upon the right concept, the right problem we wanted to solve. We asked ourselves, what should we do? The motors are 100 kilowatt and up. We can't design a scooter definitely. We saw 3% of trucks constitute all the vehicle numbers that we have on the road. But the particulate matter is 60%, emissions is 38%, carbon monoxide is 40%. And it's really, really bad. So unless we target that problem, doesn't matter if we make millions of motorcycles, we're not going to be inching towards solving this problem.
And that's a very interesting thing that you said. What I will go down deep in terms of various aspects that you have for your businesses. But what sort of struck me is in India, building something out of scratch That's not a very innate trait that we have had, right? There are not a lot of global companies that has came out of India. Mostly people sort of build stuff that is exclusive for the Indian use cases itself. But you are out here right from the start, right with Adam. You've always sort of thought about building something that is from a global perspective. So where did all of this sort of tinkering or entrepreneurship, I think, came from? Because this is not something that we are taught in schools.
So it's sort of, you can say it's a bit of patriotism, bit of naiveness, also a bit of challenging the status quo, but it actually comes from the embarrassment that we are the largest populous, like most populous nation in the world. I'm using language which is not ours, using the communication system which is not built by us. There's not even a single product probably in this room which is made in this country. And that's sort of, it's not a good trait for a country to have. I just wanted to change that since childhood. Why can't we have the best products in the world? And I'm slightly dyslexic. It is easier for me to visualize things. So that's where the hardware product comes in together. I can imagine multiple things getting together and being built. And that's where the whole of this 𝐃𝐞𝐞𝐩 is actually coming from. To actually make it, not just assemble it, not just borrow stuff.
So coming back to Tresa then, where did the concept of building the motor came into the picture in the first place? So this was very early, right? This was in 2014, 2015. This was way early for even like Tesla started being like a cool niche product during that point of time. And even they weren't sort of talking about, with the semi trucks or, with the roadster or anything of that particular sort. They were stuck with Model S, Model X during that point of time. So where did this particular idea came into the picture of building the motor in the first place?
So as I shared, like the notioning journey, it was a heartbreak. I can't explain how dreadful the day was when NVIDIA sent the mail that they can't supply the processors anymore. The 2 years of hard work and maybe 25 hours a day kind of effort had gone in making that product and promoting it and designing everything around. And suddenly, like the company comes in and says that, sorry, you can't have it. That was sort of a slap on the face that you have to own the core IP. You'll not believe Tata Motors today for their diesel engines buys engines from Cummins. Every single car on the road, including Tata Motors, buys from Shanghai Automotives. Mahindra Born Electric is buying from Volkswagen. Then you have Ashok Leyland buying from Dana. It's surprising why we don't have these motors being designed here. So that was a key thing that we don't want. We want to make sure that the core IP is in-house, that in future people can't come in. And why can't we supply motors to these OEM? You might have heard of a K7 engine. K7 engine is built by Renault. It goes in Nissan Duster. Micra also goes in Mercedes C-Class. So you can design products which can actually be cross-functional and can be actually used by different companies as also.
Interesting. So you essentially built the motor first and then sort of took the route of being an OEM for the motor itself. So in case you have, essentially you have your own motor, you have your own powertrain, and then is that a separate vertical from Tresa, or all of it comes under the same company itself? So
a correction on the motor side. It took 6 years to get the concept of the motor right, but we still couldn't finish it. Finally, so that company rolled on in 2021. 22 we started Tresa, and the engineers at Tresa finally figured out how to get that motor right, because there were a lot of challenges in getting it right. We have a very beautiful team on the motor design side. So we are a proper OEM, and if you know, Tesla also supplied battery packs initially to BMW. That's how we're looking at our components. But once our components are proven on our own vehicle, then we can actually become an OEM we can become a component suppliers for others. We just want to make sure that components work really well on our own products first.
So essentially, why do you think that it took 6 years to build that particular motor? What is it that goes into building a motor of this particular capacity, and why essentially it took 6 years for you?
So probably if you were in Germany or UK or some other country, it wouldn't have taken this long. The know-how is not there. Indians probably are actually not known for teaching. We hate teaching, we hate sharing what we know. We feel that if you share what I have, suddenly I'll have nothing left inside. So there's a big gap between what you want to know and what people are ready to talk to you about. And funding was also a big problem. I invested my personal savings into the company, but that's not good enough to hire the best engineers. So it was function of time, it was function of technology maturity, function of silicon carbide, MOSFETs not being there at a low cost for us to be able to burn more of them and get it to the production ready capacity. But finally, everything came together around 21, 22 when we got the right team, right funding, and we were able to start.
So you mentioned that it took the right team, and in a space where if you go down the engineering route, you still don't have a dedicated course for electric vehicles in India. You might have automotive engineering, but which is more catered towards the ICE counterparts and not towards the EVs. So how did you find that team for yourself, and what was that journey like? Because this is, I'll tell you why this particular question, because I was reading about this article a few days ago where uh, essentially us as as a country, it was never in our DNA to build institutions. It was never in our DNA to build bigger companies, right? Which is looking at, let's say, 50 years or 100 years down the line. Tata is one of those examples. Tata's has built something which will last them for like 100, 200 years. That one trust element, that even if you're selling salt, that sort of means trust. And even if you're selling a car, even that means trust. That is a journey that they have sort of developed. So it's an example of bigger institution. But essentially there hasn't been many of these cases. We were too used to the Britishers coming and setting up these institutions for us. So we lacked that particular era in the Industrial Revolution. So when you faced that challenge, right, where you wanted to build that team who will help you build that IP for India, and you will set everyone on this particular journey for the next 50-60 years, where there's constant innovation, constant products, constant newer things being developed in India or in your company in itself. How you're building that culture, how you're finding that particular team, and essentially third part of that question would be, where do you want to sort of take this company in the next 50 years?
So before I actually got fully involved in Tresa, a partial team was there, but it was sort of non-functional. See, the task of a CEO is to get people who are better than him in every single aspect and give them all the freedom. So, for instance, when we burn our motor, we celebrate. When we break something down, we actually celebrate. So the engineers we have, I just have to empower them, trust them, and ask them to believe in themselves. And we do not have managers here. Every person who we have has to go to Peenia, for example, or JC Road, get the components, sit in the manufacturing facility, work with the guys who are actually making these, come back, revise the design, and go back again. So it's actually a trust which actually needs to go in these particular teams. But we have really super special people. You can call it serendipity that I happen to found them in the company and just help them do what they can do best. That's literally the core of it. And as we are hiring more people, I'm again trying to find people who are really good in what they want, and they want to join Tresa because they want to really make something, not because they are looking for a salary jump or they're getting bored in the company. There's some cultures which are really toxic. We tend to avoid such companies as well. But generally, people, it's not just me. There are a lot of engineers who are also frustrated. If you look at what the other engineers are doing in their companies, most of the engineering happens in Germany and US, and they get the background works to finish up, writing requirements, writing test cases, and they are super genius as well. So there are people who are really ready to jump ship and actually test out their journey with us.
Yeah. And the last part of the question was, what is your aspiration, for the company? Where do you see this moving towards in the next 50 years?
Yes, so Tresa is going to be on the mobility and electric mobility. So that is not limited to land. It can go in different areas as well. But again, the IP is very important for us. We want to make sure that Tresa can become a global OEM. Our dream is to be in Germany and actually then tell Daimler that, okay, now let's compete. Like, why can't we do that? So we want to become a global OEM, which makes one of the best vehicles in the market, looking at what technologies are coming in, being at the state of art, making sure we are able to push the boundaries, while also making sure that our products are the safest in the world. Electric vehicles are very, very dangerous. I'm not sure if you've seen a lithium battery exploding in front of you. If you have, then you know that it's a very dangerous field. But fortunately, it's also getting safer and better as time is progressing. We really want to take India in the forefront of the automotive industry, not limiting to land.
So, sort of taking the conversation back to the truck then, India as a country, trucks have been there for decades at this point of time, and we have probably one of the most unique designs for trucks all over the globe, right? It's a really compact sort of design which is able to maneuver through smaller roads or the ghats that we have. Doesn't matter what the terrain is, the trucks would be there. So I think that was a very natural evolution that OEM sort of did to the design of these trucks over the years based on the experience that they had. Now, your truck's design is pretty unique. It's pretty futuristic, pretty cool looking, pretty 2023. But is it something that the industry requires? Is it out of practicality, or is it out of just making the product look cool?
So it's actually on the practicality side. Anyone who looks at a truck says that we got inspired from Tesla's Cybertruck. Has nothing to do with it. This design is something which I made somewhere around 2014. And I did that because when I was making my own tablets, you'll not believe the most expensive component there was a magnesium chassis to hold the whole product together, which users don't see, they don't touch. The most expensive part of any automotive design is the tooling of the body. Any curved surface you see needs a high-strength steel tooling to be done. It might cost somewhere around 2 to 25 crore. If I design a cool-looking curvy truck, I'm going to spend around 250 to 500 crore just on tooling side. But the design we have right now allows us to do something like a laser cut and just weld it. So this is actually coming from the requirement, making sure that the cost of development is actually pretty low compared to what's there. And we also want to design something which is unique and which is going to remain as a classic design and never seen before. We want the truck to be seen as something which maybe Shah Rukh Khan wants to buy to drive to his movies, and at the back he can have his camper van. Inside is also pretty cool. We have not shared the interiors yet. It's a center drive. You sit at the center of the truck, not on the left or the right. And the seat is also air suspended. The cabin is also air suspended. We're designing for European standards. But the structure and the way it looks comes from the fact that we wanted to make sure that we have as less tooling as possible.
Then if your aspirations are, of course, the trucks market would be, let's say India is one part of it, but there are also other countries that you would necessarily export the truck to. But then why start the company in India and not in US? Is that a particular reason?
Yeah, again, goes back to the same thing why I started notioning in India. If I was doing hardware, I should have been outside. But the point is that I want our generation to be the last generation asking this question, why India? We have to take the call and make sure that the engineers are around. There's something about manufacturing which people in India don't understand. Let's say you're doing a plastic tooling and you inject your plastic fillets into the machine, you get a plastic component out and you dry it out, and suddenly you see you have some warped surfaces. But if you go to China and if you go to a country which is doing manufacturing for quite some time, the temperature is controlled, the amount of time the plastic component spends inside the machine is controlled, how we anneal it back to normal temperature is also controlled. So it takes a lot of time to actually understand manufacturing, how to design precision components. So if we were outside and suddenly we come back to India, we'll not be able to find people who can actually manufacture stuff. We want to make sure that we are the last generation to learn or to teach this to rest of the country and rest of the people we have.
So in India, if you see in the last 3-4 years, especially after the FAME 2 subsidies, the EV adoption has really gotten very serious. I mean, it's not a fun or it's not a very something that you would joke out of. It is a very practical day-to-day. Every common man is buying two-wheelers at this point in time. So in the two-wheeler space, EVs are really becoming like a serious purchase option. Even in the four-wheeler space, if you're in the sort of space for about, if you know your use cases properly, like let's say if you just want to drive around the city, you know what purchase you want. If your majority of your driving is outside of the city, you know what purchase is there for four-wheelers. So there are multiple options, and even in terms of charging infrastructure, it is catching up. There are multiple charge point operators in India who are doing that. Interestingly, in the LCV space, 56% of all LCVs sold are currently electric. So in that particular space as well, electric is sort of one of the most serious options that you could sort of get right now. But in this truck particular space, it's very difficult to make a truck electric. Of course, your battery size increases, your motor output increases, your entire cost sort of increases by multiple folds. So why essentially do you think first part of the question is why essentially you think that it took so long to have electric trucks here in India, and what are the typical advantage that an electric truck would have over your normal ICE trucks for logistics?
See, it again goes back to the component. So it's not just India. Even so, if we keep China outside, even Europe is taking time to pick the electric truck part up. An electric truck in general is going to be around 50 times more powerful than, let's say, a scooter. It will have 100 times more energy than a scooter also, because it actually does way more distance compared to others. and battery technologies have been improving as we speak. Now, the cost of the battery somewhere around 2022 reached a point where electric trucks suddenly seem feasible. By the time we hit 25, 26, suddenly we'll be able to compete with at least a low-range diesel truck. So the majority of the factor actually goes back to availability of the component, the availability of motor, and the price of the battery. If the battery was somewhere around, let's say, $50 per kilowatt, or $50 per kilowatt in 2016, I think by 2020 we would have had all the electric trucks. But even today, it's somewhere hovering around $100 per kilowatt. So it's a function of the cost of the battery.
So is it just the cost, upfront cost, that sort of is sort of a bigger challenge, or there are more aspects to it? Because you need to see that people who are driving these trucks are not necessarily the most tech savvy people that you would have. So what they essentially require is just a steering wheel, the basics that go around. They want to have that like the satisfaction or that safety net that no matter where my truck breaks down, I'll find a local mechanic who can come and fix my truck. Do you think that is going to be like one of your bigger challenge for adoptions?
Not for us. We have been extremely strategic in the kind of investors we have picked. One of our investors has the largest service centers for the trucks in the country. So the moment we launch, we'll have the service centers all distributed across. So that's how we are thinking as a company also. Now, just as an example, the total number of service centers for Tata is way more than Ashok Leyland, is way more than Bharat-Benz. And this is in the order of the market penetration they have. So total number of service centers is directly going to affect the total number of trucks on the ground, because even if your truck is, let's say, extremely good, then it breaks down rarely. But you still want to know that within 50 kilometers you have a service center to look at. But again, going back on the points, it's the battery and the availability of the component. Something which does like 250 or 350 kilowatt kind of motors, they have recently started coming out. This kind of performance was only required for, let's say, a supercar or a luxury car in the electric space, but not on the not available outside. So it took a bit of development time for the motors and the battery pack. But if you combine these two, then you actually get the right, you can say, masala for an electric truck.
Interesting. And how does the economics work out for, let's say, an average logistics guy who is from Mumbai, who has 5 of your trucks compared to IC Ashok Leyland or something else?
Yeah, so based on our calculation, it should take 2 years to break even. And when I say break even, we're talking about, so electric truck is going to be expensive. Now, if you ask me what is the cost of an electric truck, the reverse question I'm going to ask you, what range are you talking about? If you're talking about a 150 kilometer range truck, then it's actually same as diesel truck. You're talking about 2025 prices. If you're talking about, let's say, 400 kilometer truck, it's going to be double of a diesel truck. If you're talking about 600 kilometers, it's going to be 3 times. So it's dependent on the range. But even for the 400, if you're actually driving a truck, let's say 300 kilometers a day, and you're doing 300 days a year, you should be able to break even in 2 years based on taking electricity from the grid. If you're taking electricity from a solar farm of your own, then you will break even, let's say, in 6 months, 7 months kind of time frame.
It's interesting because what Tesla's strategy with the Summit truck, and they just started rolling it out. It's the bigger companies who have their certain ESG goals that they want to abide by. So it's your bigger PepsiCos and Walmarts. All of these guys are essentially buying all these trucks for their essential logistics, where the charging infrastructure becomes like a very easy sort of thing, because you essentially need to set up chargers from one plant to other plant, right? And so your distances are covered. Is this something that charging infrastructure is something that you're sort of thinking about at the moment, or is it too early for you?
No, the India strategy is actually going to be similar. Electric trucks are going to be bought by companies who have a predefined point A and point B, because the charging will happen at night for electric trucks. A 50 kilowatt charger is a fast charger for a car, it's a slow charger for a truck. For a truck, you need a 500 kilowatt hour charger. Those chargers are yet to be there in the country. The max we have found is somewhere around 350 or max 400, but 500 or 1 megawatt kind of chargers are not there in the country yet. Things might change by 25, 26, but initially everyone who knows exactly the point A and point B is where the trucks are going to be sold. And 27 is when we are seeing that person who wants to go from A to any location will actually go ahead. And this will happen as the penetration of the charging stations happen. And that's something we also want to do. So we are also going to be strategic here, because we don't have infinite money. And there are 10 main arteries in the country where around 50% of the logistics flow. So if on these 10 highways we can install enough chargers at 100 kilometer distance, then we have covered 50% of the total available market.
So, is megawatt charging that you're something looking at? Because for megawatt charging, then again, your connector sort of becomes completely different. So it's not the normal. I'm assuming that you have CCS2 connectors for your vehicles, which if you're using that, then you are able to utilize the existing charging infrastructure that is already there. So let's say you also set up across all the major highways, but then you will also have access to rest of the charging infrastructure that normal cars are using. It might be not as fast as let's say your 360 kilowatt or 400 kilowatt dispensers, but it would give you essentially some amount of energy to go to the next super fast charging station that you have. So is megawatt charging something that you're looking at?
Yeah, we're looking at that, and we want it to be compatible to the rest of the system as well. But the megawatt chargers are something which will probably come somewhere around next year, July, August kind of time frame. So we had to explore that. There's a new charging connector which is also in use in US now. Tesla promoted that, and now other car manufacturers are also jumping on that. So we need to see whether that gets promoted in the country, and those chargers also support way higher capacity. But of course, the CCS2 needs to be there to make sure that we are compatible, and our chargers are also compatible with other manufacturers as well.
Essentially what we are seeing, because we follow this charging space pretty aggressively, NACS as a charging standard in US, since Tesla already had about 12,000 chargers already on the road, so it made sense for other OEMs to adopt that. But in Europe is pretty strict about their own standards. They made Apple change from Lightning to USB-C, so that's a very difficult take to sort of have all of the existing CCS2 chargers in US to in Europe to change to NACS, and India necessarily would follow what Europe is doing. So having NACS, at least that is what I feel, having NACS in India might be a sort of difficult, even though we have seen many Teslas in India. So we've seen like there are 4-5 test vehicles of Teslas in India which are having the CCS2 standard, so that might be something that sticks.
Yeah, it's a completely evolving space, and depending on
you never know what will happen.
Yeah, we have no idea at all. We need to be agile. We need to make sure that we can move faster compared to the rest.
Essentially for this particular segment, again, the reason why I'm asking more about this segment is because it's very unique and it presents its own challenges. One of the challenges, as you mentioned, was the price of battery and the size of battery. When the size of battery increases, your weight of the entire truck also increases, which may or may not present unique problems. Necessarily, the debate for this particular segment is always either it's going to be electric or hydrogen. There are very interesting sort of products coming out of Europe for this particular segment, which are hydrogen fuel cells based. So what is your take on it? Is there any particular reason why you went for electric compared to hydrogen?
Okay, so most of the world which knows about hydrogen versus electric, the knowledge is from 2018-19 kind of spec. We forget that we need somewhere around 744 kilowatt of energy to do electrolysis and finally get 100 kilometer range on hydrogen. Whereas you need worse 144 kilowatt of energy to move 100 kilometers on electric. Hydrogen on economics is 5 times more expensive just on the electricity side. Right, so we are saying that we'll generate 744 kilowatt of energy and then move 100 kilometers on hydrogen, whereas on electric 144, 100 doesn't make sense. Another fact we forget is that the hydrogen cylinder which is there on the truck is going to be 300 or 600 psi. The gas cylinder at our house is like 100 times lower, and we are saying that we'll set up this 600 psi hydrogen container, 400 centers in Bangalore and every city in the country, and somehow we'll also figure out the 7 times more expensive way of generating hydrogen or generating the. So overall economics point of view, I don't think that we have figured out, unless we have a nuclear fusion reactor or someone who invents that and we can actually get hydrogen at a very low cost. This whole thing doesn't make sense if it is coming from the renewable source of energy. Nuclear fusion comes in, I'll immediately move to hydrogen, because now suddenly we have a really good amount of really good source of energy. Now second, we are also saying that batteries will never get cheaper, they are never going to get lighter, but we also forget that in last 4 years they've actually gotten lighter by 50 times or 50%, and they're also way cheaper compared to what they were 6 years ago. From $171 to now they are $100. In next 5 years, this is also going to fall around 50%, both on the density side and on the pricing side. Now, when that happens, the amount of load you're going to carry extra for the hydrogen fuel cell and the hydrogen tanks and other stuff is going to be similar to a battery. Then the comparison is going to be on the economic side. And economically, hydrogen is going to be around 5 times more expensive than just using electricity.
And the transportation of hydrogen is very difficult. I mean, it has its own sets of challenges.
Yeah, you'll have thousands of Hindenburgs moving all across the country. That's a dangerous situation to be in.
So, according to you, what does this sector look like in 2030? What would change? What sort of things or newer players do you think would come into the picture? What do you think the legacy manufacturers would do in this segment? What is it?
So, battery chemistry will definitely change. It may not be LFP or NMC by 2030. There's going to be much better chemistry, which is lighter, can store much better energy content also. That's definitely going to keep on changing. And that's a challenge for cell manufacturers. Legacy OEMs till 26, 27 are just going to retrofit their own truck. If you see what others are doing, they're adding batteries on the sides of the truck. That's the first thing which is going to get impacted in an accident. They are removing the engine and putting a motor instead of the engine. That's not how electric trucks will be designed. Electric trucks will have e-axles, reducing the overall weight. And again, the importing components from companies like Dana or let's say Meritor and integrating into their own products. So by 27, they are allowing startups like us to go out, tell people, solve some of the problems, and then by the time 26, 27 come with a big manufacturing and marketing muscle and then prove everyone that we are the best. So we literally have around a couple of years to make sure that people trust us more than the legacy OEMs.
Interesting. So when are we going to see the Tresa truck out here in the open?
It's already out there in the open. So if you come to our company, you can see that. But the strategy we are following is that, let's say if you ask me, when are we hitting manufacturing? I have a dream date, but then there's a realistic date as well, right? So dream date can be as early as 1st Jan 2025. But what we want to do is next year, we want to clock around 1 million kilometers on around 50 to 100 trucks. And once we have these 1 million kilometers clocked with our partners, we are entering trials with our partners. We know the truck actually is working and it's actually giving the TCO we are expecting, it's actually giving the efficiency we are expecting, then makes sense to enter production. Because the first sector is going to be B2B. So even if the trucks are available for sale, a normal person should not actually buy it because he'll not be able to charge it. He'll have to wait for a week to charge on his home connector.
Yeah, it'll take a long time. We'll sort of wrap up with the last question. So this is a question that if you've seen the podcast, you know that what question I'm going to go for. But this is a question that we ask all of our listeners. It's essentially, it might be a bit frivolous in nature, but it always gets a very unique perspectives out, from individuals from various parts of the industry. And the question is that if you had the opportunity to influence the rest of the EV industry, and what would be that one suggestion?
Yeah, I'll move the FAME 2 from the OEM to the component suppliers. The FAME subsidies should be for the component suppliers, not to the OEM. If the components are cheaper, the vehicle is going to be cheaper. But now what we have done, we have allowed the OEMs to take the money, go out, buy from China or somehow get it rebranded as an Indian product and use it. And we are literally not allowing the component industry to go ahead. If you see the PLM scheme which also came out, it's not for the component supplier. As a government, they have to make sure the component suppliers are actually doing better. And that's how the rest of the companies can actually make cheaper products.
Interesting. True. I think from what their perspective might be is that if there are more people buying the vehicles, then these OEMs may place more number of orders.
Indians are way smarter than we actually are. Loophole for every single thing. Chinese are always going to be cheaper than Indians. Chinese products.
True.
I'm sorry. Yeah.
True. Interesting. So, thank you so much, Rohan, for being on the podcast. It was very interesting for us. It sort of had very unique takes on the market, on what India needs to do, and what this segment sort of essentially functions. Thank you so much.
Thank you. I'm also learning every day. Thank you.